Today we're doing the third set of notes on the matrix chapter. So first thing that we're going to talk about is determining if two matrices are the inverse of one another. And the way we determine that is we multiply A times B, and we also multiply B times A. And the goal is that I would get the result of 1, 0, 0, 1. And this is what we call the identity matrix. So for the next set of examples, we're going to multiply the two matrices together, A times B and then B times A. And if I get the result of 1, 0, 0, 1, then we can determine that the matrices are inverses of one another. So here we have a 2 by 2 and a 2 by 2. So don't write too large because you have to fit all of this in that spot. So first thing we're going to do is multiply A times B. And remember, it's that whole idea of row by column. So I'm doing 1, 2, 3, 4. And that's negative 2, 1, 3 halves, and a negative 1 half. And remember, it's that whole idea of row by column, row by column. So we're doing our rows by columns. So for the first value, we're going to do 1 times negative 2, which is negative 2. And then we do 2 times 3 halves, which will be 3. And then going over to the next spot, we're going to do row 1, column 2. So 1 times 1 is 1. 2 times negative 1 half is negative 1. Second row, 3 times negative 2 is negative 6. And then 4 times 3 over 2. So 4 times 3 is 12. 12 over 2 is 6. And then the last spot, we're doing row 2, column 2. So 3 times 1 is 3. 4 times negative 1 half is negative 2. So when I multiply A times B together, I get the result of 1, 0, 0, 1. So in terms of the problem, we're about halfway there. We know A times B is the identity matrix. Now we need to figure out if B times A is also the identity matrix. So I'm just going to write this in the opposite order so I can multiply these two together. And again, row by column, row by column. So I'm doing my rows by columns. So row 1, column 1, negative 2 times 1 is negative 2. 1 times 3 is 3. Row 1, column 2, negative 2 times 2 is negative 4. 1 times 4 is positive 4. Row 2, column 1, so 3 halves times 1 is 3 halves. Negative 1 half times 3 is negative 3 halves. And on our last spot, row 2, column 2, 3 halves times 2 is 3. Negative 1 half times 4 is negative 2. So when I add this all together, I get 1, 0, 0, 1. So since I got the identity matrix both times, that's enough to determine that A and B are the inverse of one another. So we're going to skip the next example, the 3 by 3. We're not going to do 3 by 3, so we're going to stick with 2 by 2s. So go ahead and flip the page. The next thing we're going to talk about is how to find determinants. And there's two scenarios, so I'm going to show you the 2 by 2, and the 2 by 2 is much easier. So a determinant is one single value that represents a matrix. So if I have a 2 by 2, and we're just going to use letters for right now, the determinant is determined by doing A times D, so the product of A times D, minus the product of B times C. And you'll obviously get a numerical value for this answer. So that would be your one single value. So 2 by 2 is very easy. 3 by 3s are much more involved. So here we have A, B, C, D, E, F, and G, H, I. So the first thing that we do for 3 by 3s when we're finding the determinants is whatever the first two columns are, you're going to simply take them as is and copy them over, just as you see. So after you write the columns like this, we're going to create the same diagonal. So notice for that 2 by 2, we want left and then we want right. So we're going to follow that same process here. So going on a diagonal to the right, we connect A, E, and I. So the first product will be A times E times I. plus, then you make your next diagonal of connecting 3. So plus B, F, G. And obviously we'll have numbers in here when we do another, like a real example. This is just the general case. Then I do one more, BDH, or CDH, sorry. And that's it for the positive direction. Notice the other values, so like A and E are here, but there's only 2 values, and since it's a 3 by 3, I need to be able to connect 3 values at a time. Now we subtract, and now we're going to go the other direction. So going the other way, we're going to connect G, E to C. So that product is C, E, G. And we do A, F, H, and B, D, I. So obviously you can see the 3 by 3s are much more involved. As long as you be careful and take your time, you should be okay with finding that value. So I'm going to show you how to do a 2 by 2 and a 3 by 3 with numbers. So the next example is a 2 by 2, so they want you to find the determinant, so A and D, so you do your 3 times your 5, minus the 2 times the negative 1. So I have 15 minus a negative 2. Double negatives turns positive, so the answer is 17. So again, the determinant is one single value that represents your matrix, so the answer is 17. That's it. So now on to the 3 by 3. First thing we do is copy the first 2 columns over exactly as you see them. And now we're going to start that process of connecting on diagonals of 3. So going to the right, my first product is 1 times 4 times 2. And I recommend not using parentheses, just using the dots for this. Then I have 0 times negative 1 times 3. So 0 times negative 1 times 3. And then negative 2 times 0 times 5. Now we're going to subtract, and we're going to go the other direction. So the other direction, I have negative 2 times 4 times 3. 1 times negative 1 times 5. And lastly, 0 times 0 times 2. And now that I have it all set up, the last thing we have to do is just calculate these products. So the first product, 1 times 4 times 2, is 8. 0 times negative 1 times 3 is 0. Negative 2 times 0 times 5 is 0. Minus negative 2 times 4 is negative 8 times 3 is negative 24. 1 times negative 1 times 5 is negative 5. 0 times 0 times 2 is 0. So I have 8 minus a negative 29. Double negatives make a positive, so our final answer is 37. So the next thing that we're going to have to do is directly we're going to find the inverse of any given matrix, and you need to know how to find the determinant for any given matrix. We're typically just going to stick with inverses of 2 by 2s instead of 3 by 3s. So on the next page, to find the inverse of any given 2 by 2, so if you start with your matrix A, B, C, D, the way we find its inverse is doing 1 over AD minus BC. And remember, this value right here represents the determinant. And then we scramble up the matrix. So A and D switch spots in the matrix. The other two stay the same location, we just make them opposite signs. So this is the form to find the inverse of any given matrix at any given time. So for the first example, we're going to find the inverse of this matrix. So to do that, do 1 over A times D, so that's negative 3 times 3, minus negative 1 times 6. And then we flip-flop this matrix, so A and D switch spots, so the 3 and the negative 3 switch. 6 stays where it is, but it becomes opposite. Negative 1 stays where it is, becomes opposite. So I have 1 over negative 9 minus negative 6. And those double negatives are going to turn positive. So that fraction out front is negative 1/3. And now we have to multiply this negative 1/3 in to all of these values, and that will represent our matrix. So the inverse of A will be negative 1, 2, negative 1/3, and a positive 1. And again, I got that by multiplying this negative 1/3 into all four of those values. So let's try one more. So again, to find the inverse, we do 1 over A times D, so 4 times 2, minus 2 times 3. So this fraction will become 1 over 8 minus 6, which is 1/2. And then we take our matrix and we scramble it up, so the 2 and the 4 switch. The 2 becomes negative and the 3 becomes negative. Last thing we need to do is distribute this 1/2 in. So the inverse of B is 1, negative 1, negative 3/2, and a 2. And to kind of tie this into what we did at the beginning of class, if you take this original matrix and I times it with my inverse matrix, the result would be 1, 0, 0, 1. So that's it for today.